Hi there, my name is Ashwin, and this is a documentation video just documenting a recent project that I got to work on. So this is called as real-time flight tracking in Airspace Visualizer. So this is a dashboard, and this is part of project. Project is part of a course called as real-time analytics at my master's degree at Chanakya University. So here goes the quick presentation, and then at the end I'll also be showing you guys a live real-time demo of the dashboard itself. So here's what we'll be talking about. So first I'll talk about the project, give a quick high-level overview, some challenges that I faced about this project, and some metrics that I finalized for this project. And then I'll also talk about the automation of the pipeline that I have implemented to basically ease the overhead. And then finally I'll also be showing the dashboard demo as I mentioned before. Okay, so let's talk about the project itself. So the goal of this project is to design and implement a real-time flight tracking dashboard specifically for the Bangalore International Airport's ATC. But of course it can be implemented for any airport across the globe. So this dashboard will provide a centralized platform for monitoring and management of flight operations at the given airport. So in this case that is BLR. The purpose of this project is to sort of enhance the situational awareness, optimize resource allocation, improve operational efficiency, all of these sort of stuff. Of course, if you are an enthusiast, you'd also be curious looking at all of this data, and I guess that's kind of like the primary application here. But the intention is to, sort of pitch it to the ATC, that sort of thing. Um, okay, so let's talk about the high-level overview of this project. So for the data source itself, I've used the AviationEdge flight API. So this is a real-time flight tracking, schedule, airline, airport info, all of that sort of stuff. So this is a REST API that is there. I'll go into why I chose this specifically in the further slides. Then I'll be processing all of this using Python and Pandas, and then I'll be pushing this to a Kafka producer, and then I also have a Kafka server running in the background. So that will be pushing it to a specific topic, and then a Kafka consumer will consume those topics, and then push all of that data to a PostgreSQL database. And then finally, this is all visualized using Apache Superset, the server for which I also have running in the background. The data refresh rate for this specific implementation is 5 minutes. Keep in mind this is not a limitation of the implementation, but the limitation of the API that we are using. So this the AviationEdge API refreshes somewhat around 5 minutes, once in 5 minutes. So hence it doesn't really make sense for us to update the application multiple times in a within 5 minutes. So data refresh rate is settled at 5 minutes here. Okay, let's talk about the challenges for this specific project that I faced. First one was data availability, and this is where the API comes in. This is aviation data that we are talking about. So freely available data is somewhat sparse, and even the ones that are available, the APIs are extremely limited in terms of accessibility, and also the rates are very low. So maybe a few requests, over an hour, stuff like that. So it's not really helpful. The solution for this was really simple, to actually use a paid API, and it turns out that it's not really very expensive as well. So it worked out finally. I think I paid about $7-8 for this, for about 30,000 requests, which is plenty. And the API specifically that I'm using is called as AviationEdge API. And the second challenge that I faced was more interesting. So this is about the nature of data. So most usual chart types don't really make sense for flight related data. Specifically, I'm talking about pie charts and line charts here, although I am using line charts in a different kind of way. But since flight data is mostly like tabular data, so in this case actually just simple tables and pivot tables were very insightful rather than pie charts and all that. Of course, I'm also using bar charts, binning these things and actually visualizing these. So bar charts are a huge help here. I'm also using mapping tools such as DeckGL, Mapbox. So in this case, I'm using Mapbox for actually visualizing the airspace itself. Okay, so now let's talk about the metrics for this implementation. So some general metrics first. There is 3 views in this application basically. So there is the view 1, which is the general metrics, and view 2 and 3, which is the inbound and outbound flights. So talking about the general metrics here, there is the number of average delayed flights, average delay, grounded flights, the details about these grounded flights, and then of course the flight schedule for that airport. And also there is the inbound and outbound flights, which is view 2 and 3, where we look at total flights, inbound and outbound, distribution of these same flights, and then also the flight tables for inbound and outbound, and the flight map for inbound and outbound. I'll be showing a demo of this, so I'm not going to go into specific details about all of these things. Before I go into the demo, I'm just going to talk a little bit about how I've implemented the backend. So this stack involves making 4 or 5 technologies working in harmony together, which tends to add overhead for the programmer. So in that case, that is me, and I'm really lazy. So hence I designed the application such that I could accommodate fast prototyping and also testing of ideas. So some features include dynamic table creation. So whenever the consumer consumes the messages, the table creation is automatically handled. So I don't have to create specific tables in the Postgres. All of that is handled automatically. I'm also loading the data automatically. So the 2SQL function in Pandas really helps in this, and in a very elegant manner actually just pushes the data to an existing table. And if the table does not exist, it also creates a table. But the if exists parameter ensures data is appended rather than overwritten. So that also helps, because we need to be able to take a note of all of the historical data. So that also helps here. Finally, I'm also doing the data transformation. So keep in mind, this is a REST API. So the response object in this case is a JSON. So to be able to convert that raw JSON into a usable table, I'm using Pandas for that, and that has really helped me as well. And the last one is more about the dataset and Apache Superset, where there is cross filtering across chats. So I can apply common filters in an easy manner across multiple chats for further analysis. And I'll be showing demo of that as well as we progress. So here comes the dashboard and metric creation demo. Let me just go to the dashboard here. Yes, so this is how the dashboard looks like. Hopefully, yes, it is visible properly. Great. So this is how the dashboard looks like. So this is view 1, view 2, and view 3 in the top left corner. So the delayed flight. So this is a big number with a line chart here, or really a trend line. So currently there is 298 delayed flights at the Bangalore airport, and then the average delay is about 21.18 minutes. So this is formatted in such a way that if this is greater than 15 minutes, it's going to turn red. And then there is 7 grounded flights, and those 7 grounded flights are actually from Air India Express, and then Air France, Air India Limited, Bluebird Airways, SpiceJet, and the Thai International Airlines. So the count for these things are given here as well. So there's also the flight schedule table here. So here we have 498 records in the flight schedule. So let's say I want to search a specific flight number. I can go here, paste that here, and then I can actually see the details for it. I can also search by the airline. I can search by the left from estimated arrival, scheduled arrival, all of that thing. I can also filter it according to the delay. So in this case, the most delayed flight left from Chandigarh, and then it is estimated to arrive at 1939, 17 to 1939. So this is GMT time in this case, and this is an Air India Limited flight. Okay, so now let's look at the inbound flight table. So in this case, there is 32 flights currently inbound live to Bangalore airport. That's a distribution of these inbound flights. So there is one from Abu Dhabi, there is one from Hamasi. Indira Gandhi, which is the Delhi airport, tends to have a lot of aircrafts coming all the way to Bangalore. There is also various more. So actually, if we look at the table here, we'll actually see those 5 flights here that are due to come into the Bangalore airport. So they're on the way, they're on en route from Delhi to Bangalore. So let's do one thing. Let's just look at let's say I just want to look at the Indira Gandhi International, the airport, the flights coming from Indira Gandhi International. If I just click on this, the data is gonna update here, and then I'll also be able to see accordingly. Okay, so Narita International. So this is a Japanese airline, but let me just select the proper one. Hold on. Okay, so 5 flights inbound. So 5 flights from Indira Gandhi Airport, and all of these are can be seen here. Similarly, I can also choose by airline. I can also choose by the airport, the left from airport itself. Similarly for outbound flights as well. So currently there is 16 outbound flights from Bangalore. That makes sense because it is currently 12:31 a.m. in where I live in Bangalore. So not many outbound flights from here. Uh, so there is two flights scheduled to two flights en route to Rohegaon. There is two to Indira Gandhi International again. So again, if I just filter that, and so these two flights have left airport, and then one is almost at Delhi right now. So that is about it. So again, there is 16 flights, and then the sum of these should also equate to 16, and then there are 16 flights are born accordingly here. So that's a little bit about this dashboard itself. This is a really interesting project that I got to work on as part of my coursework. Thought I'd just present it here because it was really nice. Thank you for listening. Feel free to ask any questions in the description box below. I'd love to answer them. And that would be about it for today. Thank you.